This lesson is on solving radical equations. Radical equations are equations that contain radicals. So here is an example, root x minus 4 equals 1. So let's take a look at the process of how to solve an equation with radicals. First up, we need to isolate the radical. Remember that if you have a root, to eliminate it, the opposite process to rooting is squaring. So in general, this will eliminate your root. So if we have the radical by itself, then we can technically square both sides and eliminate the radical. However, if we squared both sides here, then we'd have to do distribution and you'd still have a radical left. You can try it out. So let's get the radical by itself. So we can add 4 to both sides and we get root x equals 5. Now we can square both sides. We are allowed to do that. If you have a equals b, then we know by a property that we have covered in the past that we are allowed to square both entire sides, and it's still true. So let's do that here. We're going to square root x and square 5. That leaves us with x being 25. Great! Awesome! But you need to check your solutions. In this case, we check our solution. Root of 25 minus 4 is going to be 5 minus 4, which is 1. Great, it works in this case. However, checking your solutions of radical equations is really important because sometimes you get extraneous solutions, solutions that don't actually work. For example, what happens if you square both sides of this equation? Root x equals negative 1. Well, if you really think about it, you can't actually ever have a negative answer from a root because it just doesn't work that way. But if we square both sides, then look what we get. We end up with x being 1. But does that work? If we plug in a 1, that would mean that root 1 would equal negative 1. Does negative 1 times negative 1 give us a 1 back? No. So, really, really important to check your solutions. Most often they work, but sometimes they don't. Let's look at an example. Here we have a root on 3 minus x and the rest is other terms. So first step of the process is to isolate the root. So let's add x to both sides so that our root is on its own. So we have 3 minus x equals, and this will be x minus 3. Now we can square both sides. When we square both sides, the square eliminates the root because a root times itself will lead you to just the inside. So you have 3 minus x equals, but remember to write these brackets when you square both sides because in this case this actually means x minus 3 times x minus 3. Now you could distribute this or you could remember the formula for squaring a binomial. So here we have 3 minus x equals, if you square this, you should get to x squared minus 6x plus 9. Now we have an equation that has a square in it, which we have dealt with before. In the previous unit, recall that when you have a square in an equation, you want to get everything to one side equal to 0, factor, and use the 0 property to find our potential solutions. So let's try that. We're going to add x to both sides and subtract 3 from both sides. You're going to be left with x squared minus 5x plus 6 equals 0. Now we want to factor this because of the square. So two numbers that multiply to 6 and sum to -5 would be -2 and -3. So because there's no leading coefficient, we can go directly and input those numbers into our brackets. However, if we did have something here, remember you'd have to do the decomposition process. You can also do decomposition to get from here to here if you'd like to. Alright, now x minus 2 times x minus 3. One of these has to be 0, so either x minus 2 is 0 or x minus 3 is 0. That leaves us with either x equaling 2 or 3. Are we done? No. We need to check our solutions, especially when we have roots. So let's just double check. We're going to take 3 minus the number, root it, minus the number again, equals -3. So let's try it with a 2. We have root 1 minus 2, that's 1 minus 2. That does not equal -3. So the 2 does not work. Let's try the 3. That'll give us 3 minus 3, and then minus 3. Is that going to equal -3? 0 minus 3 is -3. So this one works. So this is why it's important to check your solutions, because they're not always going to work. In our case, only x equals 3 is a solution. Try this next one. Let's isolate the root, get it all by itself, and then square both sides. So subtract the m from both sides. That leaves us with negative root m minus 7 equals 9 minus m. Sure, you could get rid of the negative, multiply everything by -1, or divide by -1. You get root m minus 7 equals -9 plus m. And I'm just going to write -9 plus m as m minus 9. It's just easier to work with when we expand. Now we square both sides, and that leaves us with m minus 7 equals, and this is going to expand. Remember, when you expand a binomial, squaring a binomial, you get first term squared minus double the first times the last plus the last term squared. Again, we have a square, so in order to solve an equation with a square, we need to get everything to one side, minusing the m, adding the 7. That leaves us with 0 equals m squared minus 19m plus 88. Now we get to figure out how to factor this, because we need to factor it in order to find our possible solutions that then we can check back into the equation. So let's look at some numbers that multiply to 88, and we're looking for a sum of -19. Notice there is no leading coefficient, so we can go directly into this format here. So all the possibilities of multiplying to 88, and we're looking for a sum of 19. So we got 1 times 88, 2 times 44, 3 times doesn't work, 4 times 22. They have to add to 19, so that doesn't work yet. See here, divide by 5, that doesn't work. Divide by 6, doesn't work. Neither does 7, neither does 9, neither does 10. But 11 works. 8 times 11. 8 plus 11 will be 19. So that works, -8 and -11. So remember, sometimes you need to just keep trying. Don't stop. You got negative 8, negative 11. Those multiply and those add up correctly. Now we consider each bracket equal to 0 to give our potential results, leaving us with m equaling either 8 or 11. Now we need to check both of those possibilities. Check 8. 8 minus root 8 minus 7 equals 9. Let's see what that does. 8 minus root 1, which is 8 minus 1, is not equal to 9. So 8 does not work. 11, however, let's see if that one works. 11 minus 7, does that equal 9? 11 minus, and root 11 minus 7 gives us root 4, which is a 2. 11 minus 2 equals 9, check. So 11 works. So m equals 11 is the only solution. It is possible to have no solutions. If neither of these numbers worked, you'd say no solution. If both of these numbers worked, then you would answer both of them. Here's another example. We've got 2 roots, but we want 1 root per side. So this is good because if we square both sides, we will be eliminating the roots. If these were spread so that they're both on the same side, you'd want to get them isolated so that there's only 1 root per side. Otherwise, when you square both sides, you're going to be distributing big roots and it gets really complicated. So, in this case, we're going to have the square of the first side and the square of the second side. We've got a multiplication, so that's really squaring each term. So that's giving us 4 times 4x plus 5 and 25 times x plus 4. Now, notice we have no x squares. That's great. That means we're not going to have to do the solving through factoring method. We can just solve by getting x on one side and the numbers on the other side. So let's distribute this. We get 4 times 4x is 16x. 4 times 5 is positive 20. 25 times x is 25x. 25 times 4 is positive 100. Alright, so let's try this out. We're going to bring our x's together. So minus 16x from both sides leaves you with 20 equals 9x plus 100. Now we can subtract the 100, leaving us with negative 80 equals 9x, which leaves us x to be negative 80 over 9. Negative 80 over 9 does not simplify. You could either write negative 80 over 9 or negative 8 and 8/9. But remember, we always have to check our answer. So let's double check negative 80 over 9 into the first side. So we'd have 4 times negative 80 over 9 plus 5. So that would be 4 times 80 is negative 320 over 9 plus 5. And let's just get an approximation for that. Negative 320 divided by 9 plus 5 is going to leave us with negative 30.5 repeated, which we could have in fraction form and have it all fine and dandy. However, the part that is indicating that this is not going to work is the fact that we have a negative under a root. You'll notice because negative 8 is relatively big, if you had even negative 8 in this x plus 4, you'd still have a negative under the root. As long as one of these roots becomes negative with your answer, you know it can't work. So the one solution that came up did not work because you can't take a root of a negative. Therefore, there are no solutions to this equation. Let's take a look at a cube root example. Similarly to square roots, and squaring, cube roots can be cubed. So you want the cube root on its own on one side, and then you can cube both sides. Let's try that out. The cube eliminates the cube root, giving us 3x minus 3 equals negative 3 cubed, which is negative 27. Now let's solve that. For x, we get 3x equals, add 3 to both sides, you get negative 24, and x should be negative 8. Now, always check your answers. See what this gives us. If we plug in an x equals negative 8, you get 3 times negative 8 minus 3, which is cube root of negative 24 minus 3, which is cube root of 27, negative 27, and in this case, cube root of negative 27 is, in fact, negative 3. So, since that works, then x equals negative 8 is our answer.